We have a study done on proctored and non-proctored tests. Results are shown in the table. So these are what they got. You know, there's the N for each, and then the S bar for both the proctored and the non-proctored, as well as the variation. Assume the two samples are independent sample randoms from normally distributed populations and do not assume the population standard deviations are equal. Okay, use a 0.01 significance level for both parts. Test the claim that students taking non-proctored tests get a higher mean than those taking proctored tests. So our proctored we're calling mu1, and obviously it doesn't matter which is which, but you know, so you can pick the thing. So we're saying that the proctored is lower. So here A, you can see, remember the null is always equal. In this case, we're saying that it's going to be bigger for the non-proctored. They're going to do higher. Now I'm going to show you just how to do this on the TI. So I'm going to bring up the TI here. And actually, I was going to see if I could get this to maybe shrink a little bit this way. There we go. Okay, so I can plug this in and see the table. So I'm going to go here to stat, and I'm going to go over to tests. And first, for the hypothesis test, I want a two-proportion, two-sample t-test, okay? Because I'm doing the mean, I need the t-test. Remember, I don't know the sample, I don't know the population standard deviation, so I'm going to do a two-sample t-test, okay? And I have statistics. They didn't give me data, they gave me statistics. And so what do I got here? I have 78.69 and 10.55 and then 34. And then this is 86.77. Okay, I'm just checking, double checking stuff. 1979. Okay, and then this is 31. Okay, and now we're doing less than over here, right? So we have to click on that. And then pooled no, we're going to calculate. And so right here is our test statistic, negative 2.03. Okay, now our p-value here, so we look at our p-value, and that's a 0.01 significance. We are not less than 0.01. So we are going to fail reject. We do not have sufficient evidence based on these results. So we aren't able to prove it. Then we're going to come down here, and we're going to do the same thing, but we're going to do now a confidence interval. Now I'm going to go back to my stat menu. I'm going to go back over here, and now I'm going to go down, and I want a two-sample t interval. Okay. Now the really nice thing is it'll copy your data for you. So it should just have this all up here. Now this is where we have to get a little dicey. Okay. So we did a one-sided tail, so that whole 0.01 was in one tail. To get our results, we have to duplicate it on both sides, because confidence intervals, remember, are by nature two-sided, because it got two ends. So I'm going to double this, and I want 0.01 in each end. So if I'm then taking away 0.02, so I want a 98% confidence interval. So I'm going to change my confidence level, my C level here, to 0.98. Okay. And then no pool calculate. So right there, this is saying this bottom is negative 17.700 and then 1.542. And yes, it does because it contains 0. So this has 0 in it, so there could be no difference. Check the answer. Had this had all negative answers, then it would support ours that it is less than the proctored exams are less. The reality here, you look at that and it does look less than, but the problem is the variation is so big on both, that's probably what's throwing it off. But you can see here, that's how you do it. The TI does a beautiful job of doing it. And the nice thing is once you put it in for one, it keeps it for the second one, which is a really cool little trick. You can see it did do, it didn't do, when we do it by hand, we do the more conservative method with this, it did the exact, but my MathHub will take any of them, whether you do it by hand or you do it this way.